Hello, so we're back. Our next speaker is Rachel Reese, and I'm really excited to have Rachel here. Hello.
Hey, Tomas.
Cool. So Rachel has been working at Jet.com, and we're actually going to have a separate chat about Jet.com later on. So if you're curious about one of the largest startups out there that's actually using F#, what was their experience? We'll talk about that later. But we're going to start with a talk about microservices because that's how Jet works. So, Rachel, what's your talk about? What are we going to learn?
Today it is patterns and practices for real-world event-driven microservices. It's a buzzword mix.
Sounds like all the cool things that you need to know. So, should we switch over to the screen sharing and get ready?
That is a plan. All right.
All right. We can see you screen. We can now see your slides. And we're ready to go.
Very good. All right. All right, then. So hello, everyone. Actually, can we make Tomas go away? All right. So hi, I am Rachel Reese. This is my talk, Patterns and Practices for Real-World Event-Driven Microservices. Oof, that is such a mess to say sometimes, but this is about our experiences at Jet. So if you're interested in, more about Jet, definitely check out jet.com. We also have a blog, tech.jet.com, and the Jet Technology Twitter. So, all right. So what do I mean actually by real world? Well, I mean jet.com. So this is a screenshot of the website. We are a startup. We're an e-commerce website. We're taking on Amazon. So everything that you buy today on Amazon, you should also be able to buy on Jet. You should definitely check us out. I can almost guarantee that we'll be cheaper and, more awesome because F#. So we launched on July 22nd. We have, way over 20,000 orders per day. The first time I wrote this slide, it was it's been updated a few times, but gosh, I think we had, over 2 million SKUs. And now 6 months later, we have over 10.5 million SKUs. So we're definitely expanding like crazy. We are absolutely hiring as well. So if you're interested in working either in New York City or in Dublin, then definitely contact either me or our recruiter, Amy, AIMEE at jet.com. Anyway, enough spiel. These are some of the technologies we use. We are heavy users of Azure. I get asked this a lot on, one of the reasons that we chose Azure, and that was actually mostly, one, we do work heavily with Microsoft, and we're heavily users of .NET, but we are taking on Amazon, so we are not going to be heavy users of AWS. But we use Azure quite a bit. We have Active Directory, we use the cloud services, queues, and lots of different things. We are also heavy users of F#. So we have F#, packet library. We use Chessie, we use Unquote, the SQL provider, and Fake, and several different things around there. For our data science, we use some R and Python and SAS. It's the purple along the side. We have React and Node and Angular on our front end. And the green at the bottom is sort of everything else that we use. So when I say that, we are heavy users of .NET and Microsoft and F# products, that is true, but we are also very much, open to new technologies. I mean, we're using Kafka, we're using microservices, Event Store, Storm. So we definitely embrace a lot of different technologies here. So what do I actually mean by microservices? So microservices tend to mean a lot of different things to a lot of different people. For us, it means an application of the single responsibility principle at the service level. So, and the single responsibility principle, a class should have one and only one reason to change. So there should be, one set of functionality within the microservice itself. I also like to include the bit, it should have an input and produce an output. That's a very functional idea, but to us, again, the microservices should be functional. The benefits there, very easy scalability, especially, if it has an input, produces an output, it's, it is very functional. You're able to scale that out very quickly. Independent releasability, have one small bit of code, one small service, you're able to release just that service. It's not impacting a ton of stuff. there's also a more even distribution of complexity. And this varies by person a little bit, but I see this as a benefit. It's a lot easier to create and maintain each of the services, but it does end up being a lot harder to manage each individual service. There's a shift from the business logic over to the infrastructure. So there is a lot more infrastructure needs to run in a microservice environment, but I still think that's much better than a monolith with like 25 different projects that you have to make sure everything is exactly right before you can release. So now, event-driven. So the focus of what events actually are, the focus of your application code is to react to events. It could be a single event, it could be an entire stream of events. And what are those actual events? Any significant change in state that has happened in your domain. It's something that's past tense, it's something that's immutable, it's something that contains, only the actual relevant data to a specific transaction. Greg Young, who is, many of you folks would definitely know him. One of the things that he has said is all events should be represented as verbs in the past tense. So, customer relocated, cargo shipped, item added to shopping cart, and then if you speak French, it should be passé composé, things that have already completed. So it's very specifically it's past tense. It's something that you can't change. It can't happen again. Also, somewhat confusingly, event refers both to the event itself, this thing that has happened, as well as the notification message that's passed to the rest of the system. So that's something that you will also often see is, this event as notification terminology. This is just push-based notification. So you have an event emitter that emits these events. They travel through this event channel and eventually to the event consumer. And if anyone here uses, reactive anything, event-driven is a very reactive concept. The reactive manifesto, I believe it's, things should be responsive, message-driven, resilient, and elastic. But specifically from that, events can be treated as observables, and therefore microservices themselves can be treated as observables. And because of that, you can event source the input here. And what event sourcing is, it's more about how you model the domain rather than, excuse me, it's more about how you model the domain than events and event-driven. It's more like an append-only sequence of events. That is actually what your data store is. So comparing these things to a relational model, you have this append-only sequence of events rather than something that's capturing only the exact latest state change. And because you're capturing every single state change that has happened, you can end up replaying all of these. So, if you know the history of, a purchase, that, somebody browsed on the website and clicked on an item, put 2 of them in their cart, and then, noticed, because it's Jet, noticed that there were savings on 4 other items and maybe added those items also to their cart. And, there are events for each one of these pieces happening. And then they go, through the checkout process, and there's events for each of those. And then, you go through the post, checkout process, which is, these events are, taken off the shelves at the warehouse. They're actually packed. They're sent. Eventually, they make its way to their house, to this person's house. Each one of those is an event. And we can, if we need to change something later and go back and modify the information that we've received, we can replay this entire event stream. Say we found a bug or something. It's very easy to replay all of this. So the event stream tends to look sort of like an account history or a ledger. You have one event at the top. Maybe that's added to shopping cart. The next event could be checked out, and with maybe sub events in there. But like I said, maybe you need to add a running total column along the side to capture that information, but that means you need to compute what that running total was at each point. And that could be difficult, but by having that history of all of the events, it's very easy to go back, like I said, and replay and just recalculate that on the fly, excuse me, as you replay everything. So, if you find a bug, if you have an updated SQL schema, maybe you need to re-index Elasticsearch. All of these things are reasons why you might go through and replay the entire events. So why did we choose F#? This, of course, is the most important part of this presentation and one of my favorite bits. It's also so programming languages do evolve just very similar to regular languages. There's this really amazing chart that I found that I love looking at and playing with. But you can see that, there's C in the middle over here. There's lots of really interesting connections through all of these languages. You can see how they influenced each other. I will compare a lot to C#. So C# is over here, and it was developed by Microsoft for .NET, which is one of the reasons it's in the survival of the fittest section. You might also notice that the chart ends around 2001. So the F# line I have captured at OCaml. But you can see from this chart that they come from obviously very, very different places. And I like to set that up if I imagine this crowd knows a little bit more about both C# and F#, but it is always fun to really contrast the two. So a couple testimonials. Simon, I know, works for a power company in the UK. He first discovered F#, was while he was working at this job, and had a very standard business application. Endless sprints, lots of bug fixes, lots of new features to add, sort of endless work. He discovered F# and thought, this is really going to solve a bunch of my problems. So he and a few of the other developers on the team went off into a corner and rewrote the entire application. When they came back, they handed it over to the business folks and heard nothing. And so, he went back to them a little while later and basically said, what's going on? Is is everything okay? Is this unusable? Is it, perfect? What I need feedback here. Have you even implemented this? And they came back and said, actually, everything works fine. We don't need any other features. We found 0 bugs. It just works as we requested. He first wrote this, I think, 3 or 4 months after that original conversation. And it's now been, I think, 3 years, and they still have not come back with any additional work on the project. So, that's that's huge, right? Jan now has a different job, but when he was working for GameSys, did a very similar thing. He discovered F# and thought, this is really going to solve a bunch of our problems. So he, by himself this time, went off into a corner and rewrote the entire backend for this project, and was able to replace an entire team, I think 5 people of Java developers, just, by himself. And they were reassigned, they weren't fired, but basically, one person was able to do the exact same work as 5 people because F# was just that much easier to work with. And Kaggle, many folks here probably have heard of it. It's a predictive modeling company. They have a lot of, they'll give you a data set and an amount of money and say, if you can come up with such and such set of information, then you win, $10 or $1 million, or sort of all over the map there. But their comment, the F# code is consistently shorter, easier to read, easier to refactor. And I would say because of these things, contains far fewer bugs. If you can quickly look at something and understand what's happening, you're just going to make fewer mistakes. So this seems pretty amazing. And, I would suggest that perhaps everyone should be using F# because it is really just kind of amazing, right? But there does tend to be a lot of math, and that, not that you necessarily need to understand it, but especially with, many functional languages, some folks like to tell you about how, important this math is, and you couldn't possibly understand it, and you must have a PhD before you could reasonably understand F#. And I think that is very silly. And my main response to that is Sean, who is actually coming up next with his dad, Phil. And because when Sean was 8 years old, he started speaking at large technical conferences. I believe it was NDC Oslo. So 2,000 person conferences on F#. And one of my favorite comments on this, and I don't know if Phil and Sean were planning to say this, so I might be preempting them a little bit, hee hee. One of the reasons that Phil had mentioned that he actually encouraged Sean to go out and start speaking on F# was so that people would actually think that F# was actually so easy an 8-year-old could do this. And apparently a lot of people just got in their heads that Sean was actually a genius. But I'm here to inform you that no matter what you think, F# is actually so easy an 8-year-old can do it. So looking at a few code examples. Very quickly, a very similar set of information. The C#, even with the extra curly braces, is, roughly similar to the F#, but it is still so much cleaner. If you look at the very first line, let fetch URL, call back in URL, you have that same set of information over on the C#, just without all the, in the F#, it doesn't have all of the extra type declarations, and there's just so much extra code going on in the C#. It's a lot easier to glance at the F# and quickly see what's actually supposed to be happening there. Another example, discriminated unions in F#, and this has been something that we use at Jet very, very heavily. The C# example here, the 4 sets of things here would actually be in 4 separate different files. The F#, however, would be in 4 separate lines. So there's 4 files versus 4 lines, and it contains basically the same information. The F#, in fact, additionally has structural equality. The C#, if you wanted that, you'd still have to override equality, comparison, get hash code. It's also not properly immutable. Yes, there's a private set, but that still is mutable. So there's a lot more going on in the F# in 4 lines of code versus 4 whole files. The pattern matching, additionally, it's very, very, very easy to pattern match on a discriminated union. It's a lot like a switch statement in C#, but more powerful. So for F# you have, and I took the screenshot from MSDN, you have all of these different ways of handling pattern matching and all of these different things that you can match on in F#, where in C# you obviously only have that top one. So there's just a lot more happening in F#, a lot more possibilities. One more thing to note, the actual pattern matching would look like this. This get there via function here. So you match transport, if it's car, do something. If it's a bus, do something specific. If you forget bicycle, or maybe a few months down the road you want to add an additional, maybe there's a train stop now through your town. So you have, add train. The next time you compile, or as soon as you add train in, you'll get this warning that there are incomplete pattern matches on this expression. So you'll know immediately the places that you need to change your code, rather than having to fuss with that and discover sometime at like 3 a.m. There's also one of my favorite quotes from Tomas from a few years ago. What can C# do that F# can't? Null reference exception. So you can actually completely obviate null reference exceptions if you use option types correctly. An option type is very similar to a nullable, a nullable of a Boolean, except that it can be used on any type. You can have a nullable of a string, you can have a nullable of functions, you can have a nullable of custom types. It's really awesome. They're also nestable. You can have an option of an option of an option type, and that's not always necessarily the best thing to do, but it totally is possible. And I have seen some very useful examples of doing that at Jet. There's also, when you pattern match on this, and you can pattern match on the option type, it forces you to consider the case where there is actually something and the case where there isn't. So that none case is, by forcing that pattern matching, is really how you remove the null reference exceptions. You can also use functions like map and iter over these options, so you can have something that pipes through very beautifully and very easy to understand and to read. There's also a feature in F#, which I know we have talked about using here many times. I need to follow up with one of the teams. I'm not 100% sure they're using it yet, but our warehouse team has talked many times about using F# units of measure on, on the code that actually handles the items in the warehouse to make sure that they're shipping, say a case of something and not an entire pallet of something, and that vice versa, when those items come into the warehouse, that they have the correct unit there. So type providers, and it's for folks in the .NET world, many folks have used Entity Framework, and this is not at all to make fun of Julie, because I adore Julie as a person. I think she's wonderful, and her book is actually really wonderful. But Entity Framework as a whole there's a lot happening there. There's a lot to configure. There's a lot to understand. There's a lot to comprehend in it. There's a valid reason to have a 920-page book there. However, to type providers, as Evelina just showed, are very easy to jump in, to work with, very flexible, very, very powerful. This is an example of using a SQL type provider, which actually works with Entity Framework. And it's really 2 lines of code, lines 13 and 14. Oh gosh, and I should hurry up. Lines 13 and 14 that really go out, make the connection, and grab the data. The rest is working with that data. So type providers are another huge reason why we love it and why we supported F# at Jet. So dependency charts, and I will go through these a little quickly to get back to the actual microservices, because that's the fun part of this talk. Check out Scott Vlashin's post on this, but basically, you can follow the arrows around to see what bit of code depends on what bit of code. This tick spec, it's a very standard F# project. SpecFlow, a comparable C# project. Jumping back to the original part, you can understand why Jan was able to, maintain some F# code with, just one person, whereas something like this might need 5 people to actually maintain. And to make fun of it a little bit more, Entity Framework, can see how that might take, an entire wall to even understand where, something is. There's a lot happening in Entity Framework. So now on to the fun part of the talk, the actual guidelines and the microservices goodness. So at Jet, like I've mentioned, we use a very heavy microservice architecture. Last I checked, it was 250, maybe 300 microservices. My guess is it's even more by now, maybe 350, 400. I should get a recent number on that, but it's huge numbers. And some of the lessons we've learned on the way, since microservices are very small, there's no need to abstract. Write one service that has event store, has end service bus, has MSMQ, 0MQ, SQL Server. There's no reason for one service to do all of these things. If you try to do that, one service will do it very badly. Whereas if you have just an individual service that has each one, then you're much likely to be able to take advantage of, some of the important features that they wouldn't share with each other to really speed up your code and really, better take advantage of what's happening. Also, be functional. Microservices and a functional architecture, work very, very naturally together. And what being functional means to us, looking at data in, data out transformations. I said in the beginning that microservices should have, that sort of transformation. Think about what your inputs are. Think about what that transformation is in the middle, and think about what those outputs are. And once those inputs and outputs are defined, the service is really just a series of transformations, as you can compose and pipe everything through. Looking at problems recursively. Again, once you've defined inputs and outputs, it's very natural to look at things recursively and sort of figure out how to look at smaller and smaller chunks of the same problem. Preferring immutability, as long as we're avoiding state changes, side effects, mutable data, all of those things, we're going to naturally and very easily be able to scale, whether it's out or up. It's very, very easy. And again, these 3 things work very naturally together. It's very difficult to prefer immutability and not write functions that are, data in, data out transformations. And finally, treat functions as a unit of work. Use higher order functions. Using higher order functions, generally, you can much more easily have a much more complex workflow. I mean, just thinking about some of the OO patterns, and the command pattern and the visitor pattern, these are just higher order functions. So a lot of these big important things that a lot of folks from object-oriented languages think they need or think are important end up just sort of happening naturally in F#. So also very importantly, isolate side effects. It's if you have a microservice that, for instance, when you submit an order, something goes in update SQL, and then, added onto that piece of that bit, it sends a thank you for ordering email. That is bad. That is very bad, because there will come a time when you, like I was talking with the, event sourcing, when you want to replay all of the events that are coming into this, and as all of these events come in, it will, re-update SQL for you, but it will also send that thank you for ordering email again. And depending on when you're doing this, you might be sending a thank you for ordering email to a customer that ordered something a year ago. And that gets really awkward. The way to handle that, very simply, is to, isolate the side effects as best you can. Have your insert order to SQL microservice, and then your separate microservice that sends a thank you email. And as long as those two are separated, you can replay the event running through the SQL microservice and leave the sending thank you email microservice all by itself. Similarly, using a backup service to replay the events, have two services in production. Service one sits there and runs as normal. Have a backup service that isn't handling everything but is ready in production. Replay those events until you're completely up to date, and then just switch over. So when you do need to replay everything, just having that second service sitting there that you can be instantly live. It's sort of like having a QA environment that you end up just switching over and making live. But very, very importantly, make sure you stage a copy of any aggregate, any data store information, any data information you have until the stream is completed replaying. If you, otherwise you might be rewriting events to a table, and say you're replaying events that are handling accounts. You might end up turning off and turning on somebody's live account while you're replaying these events. And, it might be off for 10 minutes while, it catches up to being returned on again sometime later. And that's just going to look bad. So, stage a copy of this data store while you're doing all of this, and then you won't run into a problem like that. Again, it's basically just isolating the side effects. So what do our services actually look like? We found, one of the other things we do, it's very important to make sure we have some consistency. So this is my example service of price checking on some magical Nile website. It's totally a real thing, you guys. Come on. So the first step, defining the inputs and the outputs. I'm sending in a set of product information, say from our website, and from there I want to receive either success or failure. In the success case, that same set of product information with a new price. So because I'm doing a price check, I want to know what that price is. Otherwise, I should have some sort of information on how that failed, what happened, that something failed. The second step, once we have those inputs and those outputs, and I've mentioned several times that it is very important, figure out how to transform that input into that output. So this handle function, takes an input. In this case, I'm just, asynchronously returning an actual, an option type, but that contains that product price information with an actual, so there's a SKU, there's a product ID, there's a description. It's an amazing product. And, what the Nile website has, 3.96 for that information. So define then next what to do with that output once you actually have it. So you interpret that, taking that output and you match it on, whether there's, once it actually was successful, you have, maybe you want to write to event store, but you have an output that was actually successful. In another case, you might have an output that was actually, the failure. So the product price check failed. And, you might want to log that failure. You might want to retry, do something else. You might also get, nothing back in one case. And that, you might want to async return, you might want to, do something else there. But that will also, there's an additional failure path there where just because you didn't receive a failure didn't mean one didn't happen. There is a way for that to have failed. So, the final step here, we take in a decoded product, but, finally we read these events, handle and interpret everything. So we're reading in a product and we send out to this consume method our functions. And being able to compose everything, decoding and handling and interpreting, it allows this one function to be called to handle everything. It's, the composition here ends up being lovely, honestly. So next, one of the most important things, again, that we've discovered, jumping back to the beginning, I had mentioned that the infrastructure tends to be a lot more difficult in microservices. There is a shift of complexity onto that architecture. So it doesn't matter what you end up using for, to control a microservice lifecycle. Folks use Docker, some use Console. You should be using something. We ended up rolling our own, a product called Torch, because everything at Jet is named after superheroes. And so some of the things that, our product handles, the execution runtime, the deployment, the availability, scaling, we're adding in, scheduling and a dashboard and some analysis. But we found it more useful to roll our own. We were able to deploy a new build in, about 30 seconds rather than jumping through the hoops with cloud services and taking more like 15 to 20 minutes. We were also, the way we have set everything up, we wanted scaling to include adding an entirely new VM with assorted relevant services. We're able to group some services into sections, and we wanted to automatically scale, a whole group at once. So we run all of these, that bit of code, each one of our microservices actually has a YAML file associated with it. And this I actually thought was really fun. I went to look up YAML because I wasn't 100% sure what it meant. So apparently it means YAML ain't markup language. So it's a recursive acronym, which I always thought was fun. The first recursive acronym I learned about was PINE. PINE is not Elm, the email. And now I've just dated myself. I'm not that old. But even more interesting than having a recursive acronym, it used to mean yet another markup language, but was backronymed, which is a fun word, to mean a completely different thing, to focus as data-oriented. So it used to be, just another markup language, and now it's not markup language because it's data-oriented and not, markup like on GitHub that your README files are in. But anyway, so each of our microservices has a YAML file associated with it that our Torch product will read. So we have a version, the subsystem, and the subsystem is what I was talking about, that each VM, has a small set of microservices. So the subsystem, maybe you want to check prices on Nile, and maybe you want to check prices on Floor Mart. Is that a store? And of course, I'm joking. But so the name of the subsystem, the description, version of each one, whether or not to auto start the service, whether or not to compile it, and then the high availability. So it could be active-active or AP for active-passive. And active-active just means that all of the nodes are active, so that one fails, traffic goes to one of the remaining active nodes. Whereas active-passive means that there's a completely redundant instance just sitting there passive until one of the nodes fails, and then that spins up and takes over. So it requires a lot of extra hardware to have that proper active-passive. Good. So what the script path is, a library path to, and then some arguments. If there's a few other systems we have will hook into this JSON config and be able to run a bunch of analysis off this. So, in summary, don't abstract. Anytime you do, have 10 different things trying to, be processed by one service, you'll end up abstracting away features that you might end up really wanting. Be functional, and that I think is one of the major focuses for fsharpConf in general today. But it does really it's huge for microservices. Being functional lends itself very naturally to it. What I was showing with our services themselves, being able to compose, decoding, and handling, interpreting all together makes it much more easy to understand and easier for one person to jump in. Isolate the side effects. Anywhere you can, make sure that any sort of side effect, writing to a log, sending an email, especially things like this, just make sure that those are isolated into their own microservices. Use a backup service. Anytime that you need to rerun through all of the services on excuse me. Anytime you need to rerun through all of the events on with one service, make sure there's do that on a backup service, and then once that is up to date, switch over to that backup service and make that go live. Use consistent formatting. Again, the things that I mentioned about having, making sure you have inputs and outputs, making sure you have a handle and a decode and an interpret function, and just, there are very specific steps. And that way, it's much easier for developers to switch teams, to spin up a new microservice, and for everything to stay sort of, similarly formatted for ease. And also, use an outside product to control lifecycle. Like I mentioned, we ended up rolling our own, but the most important thing here is to, that the microservices themselves should not be controlling their own lifecycle. So for more information on F#, definitely check out fsharp.org. It would be fabulous if folks listening could all become members. Also check out F# for Fun and Profit. It's a wonderful, wonderful site that Scott Blashen has put together. For microservices, martinfowler.com and microservices.o have really good information. I would say also that the Jet blog, tech.jet.com, also has really good information. For event sourcing, Greg Young has a really good article, and there's a couple videos here. Definitely check out all of these. They're useful information on event sourcing, on microservices, and on F#. And that, I believe, is the end.
All right. Thank you very much for the talk. I guess we have time for some questions. So let's see if we've got any questions. And I believe if you turn off the screen sharing, or maybe we can even switch right here and see you again. All right. Very good. So we'll have lots more about microservices actually coming on later. So I guess one question is, how are you actually deploying all of these great things to Azure? So that's one thing that I would really like to figure out how to do it well.
Magic. So the way we sort of split everything up is, like I mentioned, we have related services set together. It's often we will have those set into separate projects, and so one project will contain 4 to 5, maybe up to 10 microservices. It's a little much, but we can usually deploy just a single project at once. So we tend not to deploy, a single microservice, though we can, but it's, we do sort of group. And then we do have a lot of auto deploy software set up. So there's
some magic, as you said. As you said, there's magic. Cool. We've got one question from Daniel, and he's asking, do you share data type definitions between microservices? And how do you version the microservices, and how painful are migrations?
We, to some extent, we share data within, say, a project, and sometimes within a solution, we'll have like one core set, and the team I was mentioning, that is looking at doing the units of measure, the warehouse team. I worked on that team for a little while when I first started, and I believe most of the teams are set up somewhat similarly. There's a lot of free reign at Jet to sort of handle things the way your team would like.
Yeah.
So I can speak to that team. But they, for their projects, they would have sort of a core project within a solution that would have a lot of that relevant information. It's basically a core project, and that would be shared.
Yeah.
But outside of that, we'd have sort of a bounded context idea. Outside of that, all bets are off. It's different. And there are contracts that we have in place to make sure that everyone knows exactly what they're getting.
Yeah.
I
think
I know
that's pretty good answer. There was the other part of the question, which was how do you deal with migrations?
Versioning. So I was going to say it's actually been a while since I have been on those teams, and I'm not 100% sure. I know we have a plan for migration for versioning. I need to verify what that actually is. But if that person wants to send me an email, this is a question I've had before, and I really need to track that down.
Sounds very good. So I think it's probably time for us to wrap up. There was one more question, and I'll just point people. There was a question about open source at Jet, and I believe Jet has a GitHub repo. So people interested in some of the things can look there.
We're also working on more.
Some of the people from Jet have actually contributed to a couple of the FS projects. So that's on the open source side. And I think it's time for us to move to the next topic. So thank you very much for joining us. And
thank you.
We'll be back in a second. So we'll put you on a slate for a bit, and then we'll have Sean talking to you about how people can get started with F#.